Okay, so section 6.6 is on something called using rational exponents. And a rational number basically means, it's a fancy word for a ratio or a fraction. So the question with this section is, what does it mean when you raise something to powers, and the powers are not whole numbers like x to the second or x to the third, but instead the powers are ratios or fractions? Like, what would it mean to raise a number to the 1/2 power or to the 1/3 power? So we'll see the connection between radicals taking roots and raising to powers. So that's kind of our first two goals: changing exponent form to radical form and vice versa, and then evaluating things that have fractional exponents, and then finally simplifying different expressions. Okay, so here's what it means, and actually I'll explain this a little bit different. So let's do a couple of these here. Let's do the following numbers. Okay, let's say 4 to the first, 4 to the second, 4 to the fourth, and then we'll do 4 to the 1/2. And over here we'll do something similar. We'll do 9 to the first. Actually, let's make that a bit of a smaller number. Let's do 3 to the first, 3 to the second, 3 to the fourth, and so on. And then we'll do 3 to the 1/2 right here. Okay, we'll see what each of these means. So 4 to the fourth power is that number, 256. 4 to the second is 16. 4 to the first is 4. We'll skip that one for now. 3 to the fourth is 81. 3 to the second is 9. 3 to the first is 3. So here's the question: what's happening to these numbers right here as I'm taking these exponents and I'm cutting them in half each time? And hopefully you would agree, half of 4 is 2. Half of 2 is 1. Same thing over here. Half of 4 is 2. Half of 2 is 1. What's happening to these numbers? What's the pattern? The answer is the square root of 256 is equal to 216. The square root of 16, that equals to 4. Same thing right here. The square root of 81 is 9. The square root of 9 is 3. So what happens is when you take the exponent and you cut it in half, that is the same as square rooting something. So if we want to follow that same pattern, I took the 1 and I took half of it. Well, that's the same as taking the square root of that number, taking the square root of 3. Same thing if I take half of 1 here, that's like taking the square root of 4, which is equal to 2. So here's the basic rule with rational exponents. Whatever number is on the bottom of this fraction, that number right here, that's the root that you're taking, and whatever number right here is the power that you're raising it to. So 3 to the 1/2, that's the same thing as taking the second root, or the square root, of 3 to the first power. Okay, the way that I sometimes remember this is it's power over root. The root of a tree sinks into the ground. So the root of a tree is on the bottom of the tree, and the root in this section is on the bottom of the fraction. It's power over root. Okay, that's the connection between raising something to a fraction as a power and what it is as a radical. Let's practice going back and forth between these. So write x to the 1/6 in radical form. Okay, this is the power that we're raising x to, and this is the root. So that means take the 6th root of x and raise it to the first power. That is in radical form now. Okay, let's go the other way. So this right here, that's the same thing. Z is the same thing as z to the first. So what would this be? This would be raising it to the first power and taking the 4th root. That's what that means. This number is the root, this number is the power. So it's z to the 1/4 power. That means the same thing as the 4th root of z. Let's do a couple more here. So the first one, a to the 1/5, that means take the 5th root of a to the first power. So that's what that means right there. Okay, the second one is b right here. Let's do this. This one says the 8th root of c to the first. That's the same as c to the 1/8 power, c to the 1/8, because 8 is the root and 1 is the power we're raising to. Alright, then we have this next one over here, 1c, that says write d to the 7/4 in radical form. What root are we taking? We're taking the 4th root, because the root goes on the bottom, and we're raising d to the 7th power. So that's how you would change that. And then here's the last one. The last one is a cube root of c to the -5. That means we are raising c to the -5 power over, the -5 over 3 power, because we're taking the cube root. Let's just double check those, and looks like we got them all. Okay, now how do we actually evaluate things? So that's how to change them. How do you evaluate them? So first of all, when you have a negative exponent, that means you flip it to the bottom and you make the exponent positive. So 81 to the negative 1/4 is 1 over 81 to the 1/4. What does that mean? That means take the 4th root of 81 and raise it to the first power. What is the 4th root of 81? What number times itself 4 times 81? The answer would be 3. That's the same as 1/3. This one right here says take the cube root of 216, then raise it to the second power. So there's actually two ways you could do this. You could take the cube root first and then square it, or you could square it first and then take the cube root. It's a much better idea to do this one first, because 216 squared is a huge number. What's that? 46,000. I think that's 46,656. That's a huge number. You wouldn't want to take the cube root of that. It's much easier to first take the cube root and then square it. So the cube root of 216 is 6. Okay, and it's, in general, it's a good idea that when you're taking cube roots, you just have some of them listed here, and you'll be able to find this pretty quick. You usually would never have to go past about 7 or 8. So 5 cubed is 125. 6 times 6 times 6, as we said, is 216. So now we have 6 squared, which is 36. That is the exact same as if you first did this. If you first squared that number, which I said is this huge number, and then you took the cube root of that, that also equals 36, but this top version was faster and easier. Alright, so a couple more. So negative 3125 to the negative 1/5. So we're going to flip that and make it positive, make the exponent positive, that is. Okay, what does that mean? That means take the 5th root of this number right here, and that's a perfect 5th power. It's actually negative 5. So that's 1 over negative 5, or just negative 1/5. Okay, what does this one mean right here? This one means take the 8th root of 256 and then raise it to the 3rd power. That's a lot better than first raising 256 to the 3rd power. That would be a huge number. That's the same as 2 to the 24th. So that's, you know what that is, 4,194,388, I think. That's a huge number. Much easier to do this first. The 8th root of 256 is 2, and 2 to the 3rd is equal to 8. So that's how that works. Okay. Let's do this kind of word problem right here. So here's a formula that basically tells you the cost increase for a video game. You have a video game system that costs $390. And these variables, by the way, C represents the future cost. They told us this at the beginning, but it's not labeled here. That's the future cost. This is the current cost. Okay, the R stands for the rate, which they're telling us right here. And the N is going to stand for the number of years. So in this case, 6 months is actually 1/2 of a year. So that's what we'd have to do. So really all we need to do now is just plug that stuff in. Okay, so what are they asking for? They're saying a system costs $390 now, so that means $390 would be little c. That would be the current cost. How much would the price increase in 6 months? So n is the number of years, and 6 months is half a year. So we're going to raise that to the n to the 1/2. Okay, how much would it increase with an annual inflation rate of 5.3? And we always want to change, whenever we're doing equations, we always want to change that into a decimal, because you can't put percents in an equation. I mean, you can, but they'll be 100 times too big, because a percent is 100 times a decimal. So this is going to be this right here. And how would you put that in the calculator? Well, you could raise it to the 1/2 power, but remember, raising to the 1/2, that's like taking the square root. Okay, and we want to follow the order of operations here. We first have to square root that. We first have to do the exponent, and then multiply by 390. Okay, and just to save some time, we'll plug that into a calculator. So you have 390 times the square root of 1.053. That turns out to be $400.20. So that is, at a 5.3% inflation rate, that $390 game will cost that much money in another 6 months. Okay, in this case we're going to use some of the properties that we've talked about earlier. So just to recall those, if you have, for example, exponents that you're multiplying, you end up adding those exponents. So 2 plus 3 is 5. And if you have negative exponents, we already said you flip it to the bottom and you make it positive. So we'll apply that right here. So we just need to add, in this case, 2 sevenths plus 4 sevenths, and that's the same as 6 sevenths. And that is really as much as you can simplify it, 8 to the 6 sevenths. You can't really do anything more than that. Okay, in this case right here, we're going to flip it to the bottom and make it positive. So 1 over b to the 5/6. And then we never want to have fractional exponents on the bottom of a fraction. Here's what this means. This means take the 6th root of b to the 5th. And you might remember from an earlier section, we're not supposed to have radicals on the bottom. That's not considered simplified. So let's do it kind of both ways just to show. So I'm taking the 6th root down here. That means I like to be raising that to the 6th power. And that's the same as adding another b. Because I have b to the 5th. If I multiply by another b to the 1st right there, I will have b to the 6th. So the 6th root of b to the 6th over the 6th root of b. And the 6th root of b to the 6th, that cancels and you just get b. So you get the 6th root of b. So that's supposed to be a b. 6th root of b over b. Let's do it with the fractions. How would you make that to be 1? Well, what do you need to add to 5/6 to get 1? You need to add 1/6. So that's the same as this. That's the same as b to the 1/6 over b to the 6/6. But b to the 6/6, that's just the same thing as b by itself. So notice that that answer is actually the same as that other answer. B to the 1/6, that's the same as the 6th root of b. Alright, how do we simplify things like this when you have kind of two radicals on top of each other? And what it says here is always use the least index possible. Okay, basically what that's referring to is the type of root that you're taking. So the first one doesn't look like we can even do it because we're taking the 4th root on the top and then the square root on the bottom. But let's notice something about 27 and 3. Those both are powers of 3. We could write this as the 4th power of 3 to the 3rd. And we write the bottom as 3 to the, well, you're taking the square root. So if square rooting something is like raising it to the 1/2 power. And then how could we rewrite the top? Well, what would this be in fraction form? That would be the same as 3 to the 3rd power over the 4th root, 3 to the 3/4 over 3 to the 1/2. And now how can we simplify that? Well, let's remember our exponent rules. When we're dividing powers, what we end up doing is subtracting the top from the bottom. So for example, x to the 5th over x squared would be x to the 3. So let's apply that right here. This is going to be 3 to the 3/4 minus 1/2. That's the same as 3 to the 3/4 minus 2/4, because that's what 1/2 is. And then 3/4 minus 2/4, that would be 1/4. So that's the same as 3 to the 1/4, or if you want to write that in radical form, the 4th root of 3. Either one of those would be fine. Okay, this one right here, we've kind of done this in an earlier section as a radical. Let's just change it to a fraction now. That's the same thing as 64 z to the 6th to the 1/3 power, since I'm taking the cube root. And to do that, we could raise that to the 1/3 power, and then we could raise this to the 1/3 power. The cube root of 64 is equal to 4, and the rule for exponents for that is when it's a power to another power, you just multiply. So a 1/3 of 6 would just be 2. That's the same as 4z squared. Okay, this one's a little bit harder, so we've talked about using the conjugate before. This is actually a conjugate problem. It just doesn't look like one because there's no radicals. So we always multiply the top and bottom by the conjugate of the denominator, because that will cause the radicals and the rest to go away. So the conjugate is the exact same, except this sign changes. So that's minus 2, and then this top one will also be minus 2. Now we need to FOIL this out. We're not allowed to have any fraction exponents on the bottom, so if we do this correctly, there shouldn't be. So what does this FOIL to? 3x to the half times 3x to the half. 3 times 3 is 9. X to the half times x to the half. What you end up doing is adding those powers together. 1/2 plus 1/2 is 1. So that's 9x to the 1, or just 9x. Okay, the outside terms and the inside terms with conjugates are supposed to cancel. So that is the same right there, 3x to the 1/2 times -2. Okay, what that ends up doing is basically going to have those things cancel each other out. So we really don't even need to write that, but that's the same, just to kind of show how it looks. We're going to have minus 2 times that, and then the inside terms, oops, running out of colors here, the inside terms are going to be positive 2 times that. So we have positive 2 times this right here. Okay, those of course cancel each other out, so we don't need them there anymore. And then finally the last terms that we're going to get will be these. The last terms will be 2 times negative 2, which is minus 4. Okay, now what do we get on the top? The top needs to be FOILed out as well. So we will FOIL this out. So x to the 1/2 times 3x to the half, that's like a 1 right there. 1 times 3 is 3. X to the half times x to the half is x to the first, or x to the 1, because we're adding those powers. The outside terms will be that times negative 2. Okay, that times negative 2, and that's going to be, you end up just multiplying this negative 2 times the 1. So minus 2x to the half. Inside terms, minus 2 times that will be minus 6x to the half. And then finally, minus 2 times minus 2 is plus 4. So let's just simplify this a little bit more. We have 3x. What does this equal? Well, I have negative 2 of those x to the halves, and I subtract another 6 of them. That would make negative 8x to the halves. And then we still have that plus 4 right here, so that's right here. And then the bottom is 9x minus 4, and that's now simplified because we don't have any fraction exponents on the bottom, and that's really all we needed to do. Alright, we'll take a look at, well, that's really all the problems. I just wanted to emphasize the rules for considering something simplified or not. These are the basic rules. Okay, you can't have negative exponents. So for example, this right here would not be simplified. Oops, that right there would not be simplified. But now if we make the exponent positive, it's closer to being simplified. It's not quite simplified yet though, and the reason why is the second condition. It says it has no exponents that are not positive integers. So 2/3 is not an integer. How would we make it an integer? We would need to get this number equal to 1. And what does it take to make 2/3 equal to 1? It takes another 1/3. So now we would have 2/3 plus 1/3, that's 3/3, which is another name for 1. And then this stuff multiplies to that. This is now considered simplified because it basically meets those first two conditions. Not a complex fraction, so for example, this right here, that's a complex fraction. It's a combination of fractions. That's not simplified. The way you would simplify it is you copy the top, make a dot for multiplication, and then flip the bottom. Dividing by 2/3 is the same as multiplying by the reciprocal. That's now not a complex fraction, it's a regular fraction. And then the index of any remaining radical is the least number possible. So we kind of did that a couple pages ago on this problem right here. This right here, this number is the least number possible. There's no way to reduce 1/4, the fourth root, any more than what we did. So that is section 6.6 on rational exponents. It's basically taking radicals and changing them into fractional exponents. That's the main idea.